Today, people everywhere benefit from the tremendous pace of technological advancement. Scientists and engineers are devoting their careers to improving our quality of life and that of the environment. Yet one technology, for all it's done to improve our lives, is not so apparent. It's refrigeration. The foods we eat, the environments we work in, and the medicines we depend on are all beneficiaries of refrigeration technologies. By the beginning of the last century, the Industrial Revolution had led to the development of many life-improving innovations. Some enterprising inventors were working on the concept of providing cooling from machines. In 1908, those most responsible for the advancement of refrigeration met in Paris for the first meeting of the International Institute of Refrigeration, or IIR.
At the beginning, the IIR was necessary because of the importance of the transport of food. And the preservation of food is still one of the main challenges we have because, as you know, food is necessary for life.
That first meeting began a tradition of international cooperation that has greatly improved our quality of life and allowed us to do things that even those visionaries could not have imagined. Today, scientists and engineers of the IIR come from private industry, academia, and government organizations worldwide. Together, they address issues that affect all facets of life. Through advances in refrigeration and air conditioning, members are helping to improve human health, promote effective food distribution, create more productive workspaces, support a cleaner environment, and counter global warming. The science of food refrigeration affects everyone. In a global marketplace, the goal is to make a variety of foods available everywhere, at an affordable price, and in a sustainable manner. Members of the IIR are involved in refrigeration applications that range from cold, such as refrigeration, to extreme cold, such as the near absolute zero temperatures needed to explore fundamental particles of matter. They also use refrigeration cycles to pump heat for space conditioning, water heating, and other applications. At universities around the world, ways to improve energy efficiencies throughout the cold chain are being explored.
There's a whole raft of interesting problems with food itself. There's a tendency for people to either look at the food or at the refrigeration, and there's a huge area looking at the interaction between the two of optimizing the food quality and the food safety, but also making the refrigeration system as most efficient as possible.
We look at things like packaging systems for food in the refrigerated cold chain. We look at weight loss from foods. We look at heat and mass transfer when you're processing or storing foods.
Another focus of IIR members is global food transportation.
The research that we're doing for companies is very practical. It's trying to understand how their transport system, alongside their packaging and their product, are interacting as they move product around the globe. One of the areas we've been working with is with the kiwifruit industry in New Zealand, and we're trying to optimise the container design and operation so that they get a better outturn of product quality in the marketplace.
Other IIR members are addressing efficiency in a different way. Climate change is a global problem. Scientists are looking for refrigeration processes that are both efficient and use benign refrigerants, such as carbon dioxide.
I'm doing research on carbon dioxide transcritical cycles. In general, more specifically, it's like I'm using carbon dioxide as a working fluid. Then I have some cycle arrangement to make the system work more efficiently and more environmental friendly. I feel that my work is meaningful.
Carbon dioxide systems aren't a new concept, but they are getting a new look by engineers.
CO2 as refrigerant requires development of new components, new systems, new strategies. And of course, the new systems must be equally or more energy efficient than the systems they are going to replace. And that's challenging to manage to get this developed.
IIR members are also working on efficient systems that use a variety of refrigerants, such as fluorocarbons, ammonia, and hydrocarbons.
Well, natural refrigerants are a possibility to replace CFCs, HCFCs, and HFCs, and all of them have quite a high global warming potential, and all the natural fluids don't have a high global warming potential. Some of them are poisonous, ammonia, or they're flammable, like propane or butane. So if you want to use them in larger systems, you would then have to use indirect systems.